Yeah, we're good.
Hey,
We're
Joyce.
good.
Hi, Joyce.
Do we have to
Joyce.
get our t-shirt design like submitted?
We have
Oh, wait, we're still waiting for
issues
it to
with our
come out.
health,
Yeah.
So I'm totally for the wall.
Oh, when is it coming back?
We're cutting that part out, right? No, you can't hear me from this.
Oh, but I was gonna text Vince. That's right. That's me.
Oh,
That's on
Vince.
me. I had to get through grades today first, but I did kind of. Maybe that's another part of it. I just read their related grades testing.
Related rates, I don't know.
I
It was
just
like
like-
hard to understand until a certain point where it was just like, oh my god.
I feel like I understand it better now.
Mhm.
Yeah.
I mean, it wasn't hard last year. It was just like the beginning. It was like, how do I find what the rate is? What's related?
Yeah.
Oh, what's a D? Oh, I have to find DVDT. Oh, DVDT is like a variable. Oh,
Once you find the verb and word, then you're good.
Yeah, that's what I was always looking for. Like
how they
literally,
get-
I would look for numbers, circle them, and like it was
Yeah.
like at a certain time, it was like, okay, this is such
Yeah,
that.
but see, I had probably 25% of the class. You pause it, Jordan?
No, she took a picture and sent it in the group chat.
Oh, she did that too, but she left a comment.
Oh, she did.
She's like, is this factoring wrong? So question, my amazing ones. They're supposed to check all my factoring always. Anything wrong with, this one?
It's supposed to be x minus 3 times x minus 2.
Yes, it is.
I worked out for myself. Thanks, Amanda.
So you guys had it right and I didn't. You were just like, yeah, let's go.
I honestly didn't notice until Brother just told me that now.
I was a little strange. The question I thought.
Okay, but everything else is good?
Is the 1-7 still with that?
Yeah.
No,
That'll
it's,
be different.
No.
it's not what. It's not. It's just gonna be 1 and negative 1. In that order.
So when we plug in 3, it'll be a positive 1. When we plug in 2, it's going to be a negative 1.
Yeah.
I wondered why 1/7. I didn't think it was that.
I know, I thought it was kind of weird that it was a fraction, but
Can I just erase all this as well? That may be it. We're reading that. That's the one, that's a negative 1. And then we just get to pull that out. And then that should be negative. And then this is going to be the other one. All right. Joyce, all better. We got it.
I didn't get negative. Not positive.
what?
The whole answer.
It's positive.
You just said it's negative.
Oh, there's a negative with the 1
Oh.
that goes with the ln, and then it becomes division. Is that cool?
Yeah.
Okay.
Should I fix this in my notes?
I don't know. It's up to you.
Totally worth it.
Okay. Yesterday we were talking about what the process is when we're not using the thumb trick in order to get partial fractions from an original expression, right? What would we do if we had quadratic factors? So things get a little bit more complicated.
Isn't that like cx plus d?
Yeah, let's say we had something like, let me make 1 linear, is that okay? And then we'll make 1 quadratic. Wait a minute, what's wrong with that? Why don't we just factor the x squared plus b?
We can't.
So therefore it's irreducible, that's a snazzy term for it, irreducible, and so we need to go ahead and make partial fractions, 1 for the x minus a and 1 for the x squared plus b. This is just an example. Over the x minus a, you still just use a capital A. Think of it, you need to make the partial fractions proper. Ooh, what did proper mean yesterday, do you remember?
Top
Bigger
is
on the.
or bigger on the bottom.
Degree is bigger on the bottom. I need to keep it proper. I can't put ax, because right now that would be improper, right? Or ax squared, ax cubed, so it's just an a, it's just a constant. But when I go over here to keep it proper, I technically could have an x term and a constant. Not an x squared, because that would be tied again, so it would be improper. Not an x cubed, but I could have a bx. So I have to allow for all those possibilities. That kind of makes sense? And why should I never have an improper piece over here? I should never have an improper piece over here, because if it is improper, what should I have done first? Long division to break it down, right? Okay. We're not going to go through like we did in the one before, the entire process, but question, what would we do in order to start solving, trying to figure out what these pieces are to get our partial fractions?
Multiply it over.
Yeah. Multiply both sides by that denominator.
Wow.
Because then we would just have 1 equals, and then over here on the other side, we should put a big old, there we go. Trying to have 1 equals, the x minus a would cancel, a would be times x squared plus b. Then we get bx plus c. The x squared plus b would cancel, I'd have x minus a. And I could go ahead and plug in x equals a to all the x's. This would cancel and be 0. I'd be able to solve for capital A. And I could plug in capital A. I wouldn't be able to solve for the 0 of x squared plus b, hence why the thumb trick doesn't work. We'd have to plug in maybe some other values or use some creative mathematical something or other. So let's see if we have any crazy examples like that. But once again, remember, the quadratic factors, I haven't seen them on an AP. I haven't heard of any other AP teachers really stressing about it because the BC exam does not seem to actually go into that much depth. Wait a minute, didn't we already do this one?
Oh, yeah.
Let's not do that one, that's boring. What else do we have? Oh, let's do this one. This one's more fun.
Oh, what is it now?
What? Come on, you guys love a challenge. At least that's what I told all the college people when I wrote your letters of rec.
Well,
Uh-oh.
you never wrote me a letter of rec.
Oh, just kidding. Maybe not all. Some.
You simplify it a little bit, right? Oh, wait, no.
Are we dividing?
No.
Yeah. The bottom is a 4th degree polynomial, the top is a 3rd. It's proper. But we could factor a little bit.
For the x squared minus x.
I would. You have
Do
to.
an x and then x minus 1. That's
Oh, it's a minus x. I don't know. I thought everything on the bottom was plus x for some reason.
Hang in it. It's gonna end up being. Now hold on. Technically, and Amanda Johnson, you'll feel this. Shouldn't we check to make sure that we have to do partial fractions first?
Yes.
Pretty darn good idea.
Why don't we factor?
Because somewhere in homework, I'm pretty sure it actually says, you can do this one with algebraic means, not partial fractions, so they're helping you out. But what would be happening if we could use algebraic? Now, George, you're saying factor the top, that's one way.
We could divide or use what's it called with the box, or we
Synthetic division.
synthetic division, or we could just multiply that.
Is plain old u sub gonna work?
Doesn't have to be.
So I have 4x cubed, well, I have an x cubed, I have 3x squared, I don't have an x squared, and I don't, okay, no, that's not. I don't have enough for the u sub. The other way is you could try to factor the top and see if stuff cancels out.
You might be able to get an x. No.
Yeah.
We could pull out a 2.
Can
Yeah.
we pull out an x from the bottom?
Mm,
You could do that, and that'd be x minus 1.
oh, I see what you're talking about.
I don't like that. Let's do a fraction bar. Hold on. I should do a squiggly one. Sinusoidal. Anyway, so,
Did you guys know that Bob graduated from Pepperdine? I thought of that when the things look like waves. Bob from the Science Shack.
He did? I forget, is Pepperdine the one that's a Christian school or is it the other one?
It's a Christian school, yeah.
Oh, Christian.
Interesting.
It's Christian kind of the same way Cal was Christian. There's some Christian staff and their statement is Christian. Pepperdine's probably actually a little bit looser.
Lucy Goosey.
No, not loosey-goosey per se, but they don't force standards on their students.
Yeah, they don't. They need
So they
to
have
go to
optional.
chapel.
But I think
There's
they're
like
assembly.
Oh yeah, they're like
14
they're like
chapels
seminars,
this
but
semester.
Yeah,
That's it?
yeah. And some of them are like guest speakers that are
There's
under
one that's cool, it's a surf one, where you have
Oh,
a
yeah,
lesson
yeah,
and then
yeah,
you go
I did.
surfing after.
Actually, that's I forgot about
You know that.
alright. And
Because I
then
went
for
and visited the campus.
are you applying that, Matt?
No,
Oh, I didn't think so.
man, I was going to, but there's
No.
too many schools.
Doesn't work, right? Can we try 2?
Wait, did we try factoring the top? Oh, we did already.
That's not what we're doing. If they're cubic, so we kind of just have to go for it, you know what I mean? If it was a quartic and a quadratic, we could do like little factors, but since it's that, we could try, I'm just plugging in stuff. Plugging in 1 minus, no, plugging
Can we
in
use
2, 8 minus 4. Ooh, actually, is 2?
Or Christian top.
Oh, okay, that's cool. So you can make him into, that's right, I haven't done anything illegal.
So x minus 2.
X, yeah.
2 times x minus 2 times x squared.
Plus 2x plus 2. And that would just be, I don't think you can factor that actually.
Multiplies for 2x.
No, but in the mark, 2 and 1. So x squared plus 2x plus 2.
That sounds like the difference in perfect
Did that
cubes.
help us out?
I don't think so.
That's what I thought it
Oh
was.
yeah, we got
Wait. That sounds like the difference in perfect cubes.
It is.
It's like,
It's if it's soaps. Or whatever.
no, if there was
Saying
nothing.
opposite always
If it was
works.
x cubed minus 8, that would work.
but that's the end form of perfect difference in perfect cubes.
No, perfect cubes would have, this one would be different.
Wait,
You would need to keep on
And it would be x squared.
Misty, wouldn't it be like if you took away the 2 And then you had x minus 2.
Maybe x minus 2.
Oh, is that what you're doing? Never mind, I misunderstood. I thought you were doing like so. Is that what it's called? Same opposite, always positive?
Yeah.
Is that the same thing?
Same opposite always positive.
Oh, I don't want to do binomial theorem.
No, it's okay, just do it.
We'll
We
just
got
leave
it.
it.
That's our
Because it's not
factor.
going to make a difference. It's not because this one isn't here. So we factored in, it's like, yay, nothing's really different. Okay, so, that's cool. Anyway, we come back. Long story short, we have to split up the partial fractions. True? So we have our 2x cubed minus 4x minus 8 all over our x times x minus 1 times x squared plus 4. What would our partial fractions look like, and why are there 3 of them?
Because it's x. X minus
So we need x minus 1, and we have x squared plus 4, but what would the numerators look like?
A, B, C, x plus D.
Because we need to make it proper and yet have as many pieces as possible.
True.
Just to account for the possibility of what else could be. Now, remember right now, all we're trying to do is break apart our fraction. We're not integrating, we're just trying to simplify into partial fractions. We multiply both sides by the denominator. Can I just skip? Are you guys good?
Yeah, go ahead.
Meaning, when I multiply this by a over x, the x's cancel and you get a times the other two, right? Is this okay?
Yeah.
Okay. Multiply the denominator up, x's will cancel, other two parts left. For the next part, the x minus 1s will cancel, so I'll have b x times x squared plus 4, b times the other two. Then for the last one, x squared plus 4 will cancel, and I'll have what now?
You got lots of distributing and issues to deal with.
Okay. One method is distributing.
Oh no.
Why?
Well, I guess you could say you can skip that and just be like, yo.
Couldn't you technically
You can fact.
find all the cube terms?
Yeah.
Find all the squared terms? Find all the linear terms? And find all the constants?
What's that gonna do?
You said
Have a
those, so
system
all
of four
x cubes
equations.
equal, yeah.
And then we could solve. Because if they're all cube terms, we could divide by x cubed. If they're all square terms, divide by x squared.
My question is, how is it that you can set all the cube terms equal to each other?
Because cube terms can only come from cube terms, like apples can only come from apple trees. Or the store. Or the store. And where the store get them.
I get-
Hopefully apple trees, or else we're in trouble. So, that's one way. Is there another way?
Yes.
Do you want to see the other way?
Yeah.
Do we understand this one though?
Yeah.
If we had all cubes, divide by x cubed, the cubed is gone, we have an equation with like a, b, c, d something. Okay, that's one way, but there would be 4 equations. I don't want to solve a system of 4 equations. So, another way is we could use the zeros.
Oh, I remember this thing, and I don't remember why.
What about using the zeros?
You can kind of use them to apply it.
Plug in x is 1. Somebody go, this is dumb. What are you doing? Well, 2 minus 4 minus 8. Just go with me for a second, okay? 2 minus 4 minus 8, what do we get? Negative 10, right? Negative 12 plus 2. Plug in 1. Why did I choose 1? 1 minus 1? Plug in 1. 1 times 1 plus 4, 5. 5 times 1b is 5b. Plug in 1. Poof, poof. Oh, and guess what? B is equal to? For sure? For sure.
Sure.
Why am I choosing x is 0?
Because we can't do 2 or negative 2 because
Yeah, because I'm looking at him since his factors are imaginary, but if I plug in a 0, it'll make those go poof, right? Poof, poof. So then I end up with, okay, 0, 0, minus 8, right? Equals. Plugging in 0. 0 minus 1 is negative 1, negative 4, negative 4a, right? Plugging in 0, poof, poof. A is equal to?
Yep. That was the reference I made.
Aw, stink, but the other factor doesn't have real zeros.
Good thing that you have A and B already.
Good thing we have A and B already, but we need C and D, so guess what?
Oh, we can see it.
Choose 2 other x's. Because all we need is 2 equations now that we only have 2 missing. Maybe then. But if we want to, we could plug in at least make things a little bit easier. If we want. We could go ahead and get our 2x cubed minus 4x minus 8 equals. We know a is 2, so 2 times x minus 1, x squared plus 4, plus minus 2x times x squared plus 4, plus x cx plus b. Okay, could we technically now still multiply everything out and still combine everything and we would still have x cubes and x squares and x's and numbers? Yeah. So it's up to you guys. Do you want to multiply everything out and then match up and you're only looking for c and d, or should we just plug in 2 more x's? That's what I thought. Right? But both ways technically work. So that's why, and I literally, you could have plugged in -1. Do you want to do -1? We could do -1.
We could.
-1 and like 2?
Why negative?
I don't know. Sounds easier to plug in than 3 maybe, because there's lots of like multiplying stuff. But you can plug in any 2 numbers you want. We just already used the easy one, 0 and 1, so that's a bummer. If you plug in -1, -2 plus 4 minus 8, -6. You guys double checking me. -2 plus 4, 2, 2 minus 8, -6. Plugging in -1, -1 minus 1 is -2, -4, 5. No, -4 and 5, 20, right? -20?
4,
Yeah.
5, yeah, 20.
Oh.
-2, -4, and then 5.
Oh, yeah.
And then we have negative, that'd be a +2.
Plus 5, 10.
Yeah, good. And then we have minus, I'm just going to write it because I'm
Do
being
we have C or D or no?
-1, -2, that'd be +2 times d minus c. Is that right? -1, -2, +2, and then d minus c. Okay, there's one equation, and we'll simplify them, but whatever, let's plug in 2. So then 2 cubed is 8, 8 and 2 is 16, 16 minus 8 minus 8, oh that's 0.
Oh.
Nice. 2 minus 1 is 1, 4 plus 4 is 8, 8 and 2 is 16.
I believe you.
2, 16, yeah. And then 4 and 8 is minus 32. And then 2 and 2 and 1.
4, yeah.
And then plus 2 times 2c plus c.
Sure.
Yes. No, yeah.
Or your shirt is not in confidence.
Sam scared all of us.
I think you just.
Okay. Is
You
it
can
bad?
actually feel, I don't know, I don't know.
What, you thought it was an earthquake? Is that what you were going to say? No, never
I thought
mind.
the board shook. I don't know.
I-
But someone
that
also
was
did
my-
something up there.
That was
freaks me
my
out.
first thought. I was like, earthquake.
The other
I
day,
sworn I thought, no.
the other day I was in like.
I never feel the actual earthquake, so I did feel like.
The other day I was just like, I felt so ground.
So-
I was like, did you feel that?
Add 2014, 14, 4, 4, 2. Double check me.
Whoa, what?
No.
10.
Add 2014, 14 minus
4,
10 is 4, 4 divided by 2 is 2,
Yeah.
right?
Yeah.
Okay, and then this one's going to be minus 16 plus 32, that'd be plus 16, 8. Yeah. Is that good?
And now we have to solve for C. Or no, D. So add the C. Then 8 and 2C.
Can I do that? I doubled everybody?
Wait, why?
So I can just add them.
Oh. I thought you were going to solve for D and then plug in D.
I don't like substituting.
I don't like eliminating.
Oh, that's 4.
Good. So then the C's cancel, and I end up with 12 equals 3D. So D equals 4. And then I can go back and plug in, and 4 minus 2 is 2, C is 2. Someone's double checking.
-4, then.
We just
Not
cheated.
good, yeah.
We heard everything you say.
That's dangerous, especially since I couldn't factor yesterday. So then we end up with, where on earth did this get us? A new problem. Not really, it's just a different form.
Oh, yeah. I
We
should
can take the integral of a, who's a, 2, over x, plus b, who's b, -2, over x minus 1, plus c, 2x, plus d, plus 4, all over,
X plus 4.
got it.
Now we integrate.
Yay! Go team.
So 2ln of x
You're welcome. The enthusiasm.
minus 2ln of x.
Hold on.
No, 2ln of absolute value of x minus 1. And then the last one.
No, it canceled. No, it doesn't.
No.
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 Pull out of 2. X plus 2. X squared plus 4. Integration on crack.
Hey, you don't belong.
Crack.
Go away.
Crap.
Go away.
I feel like your voice got deeper.
Go away.
It hurts a little.
Okay.
It's called Ebola.
That's helpful.
I totally forgot that
I'm
was
so
a
glad
thing.
you're here. Okay, so
I know when I'm not wanted in this team.
Oh wow.
If you tell me to go, I'll go.
Jordan, you know me better.
Do I? See, yeah,
It's kind of scary.
Better. Otherwise I'll look nice.
That's kind of scary. I do the same guilt trip on my sister sometimes.
Okay, just keep going, just keep going. Don't
So, can I make this 2ln of x over x minus 1?
read.
Yeah.
Isn't that snazzy? Pull out the 2 and then
Smells
so much prettier.
Oh,
this one. Hey, it's you sub,
2x.
right?
Yeah, we get a 2x, and then 1 over 2x, and then
No,
2x
we-
cancels. A lot of x squared plus
Dylan's
4.
tangent.
Oh, you're right.
Our tangent.
Amanda, I could show you something bad.
Oh, I was thinking about. I thought you were talking about the first one. I was like, what?
You're like, what?
Yeah,
Does that work?
we.
Because u is, now Gerardo, why did you do it so fast? U is x squared plus 4.
Oh, it's just 2x.
du is 2, right? So it's 1 over u, ln of u.
And then we can multiply.
And I can make that
I'll roll with that.
parentheses, because it's always positive. And then this one, u was x, a was 2. So 1 over u, but there was a 4 there. Tangent inverse of u over a. That's
You
good.
combine the 2 LNs.
Oh, we can pull out a 2.
Wait, can you?
Because if we combine that, we have a 2
Yeah,
ln
because
of
it's
x.
plus, so we can make it ln of x times x squared plus
But don't you first
4.
have to put the 2 inside squared?
Well, I mean, and then you can also you get a 2 tangent inverse, don't you?
Okay.
Wait, what?
Yeah, we can make that up there. Ooh, and since it's squared, that can be a parenthesis.
Mhm.
And then we can do ln of x squared times x squared plus 4 all over x minus 1 squared.
And then time plus 2 tangent inverse
Plus.
of secant.
2 tangent inverse of x over 2. But George, you're right, we could have pulled out a 2, but then we had to deal with the ln to make it all messy. Whoa! Are you proud of yourselves?
It took 2 days.
It did take 2 days, you're right.
Not this one problem. We started it today.
Oh, it's not good.
Okay.
Oh, good, you wrote 2.
I'm going to use logistic growth.
Okay, I'm good now. Is anything doing Bible today?
Reverse
Did you
result.
finish up homework?
Okay.
As you yesterday?
I was so tempted to do it.
Now, kiddos. Hold on, pencil down. Okay. You don't have this handout. Maybe I'll try to get it for you. But I want you to check and see what's going on. Do we already know that logistic growth looks like that, where it's exponential and then it levels off towards a limit?
Yes.
Okay, awesome. So, we already talked about how it's practical, how there's something called a limiting constant. It's also called a carrying capacity. But what do you see at the very bottom of this page? Where did this come from? What kind of growth is it?
Logistic. Logistic.
Say it again, what?
Integrating my partial.
Its rate is proportional to not just y. Its rate is proportional to not just y. So what do we do with that whole ky times l minus y thingamabob? We know how to do partial fractions. Forget. Oh, hey, there's this guy called Heaviside. He's the one that came up with the thumb trick. Okay. Does he look happy? Ta-da! Okay. Keep going.
That.
How would you start this problem?
Back to bottom.
Divide.
Divide. Why?
Improper.
It's improper. Then we go for it. Okay, that's all. Fast logistic growth. We already did partial fractions. I have full confidence that we'd be okay on those. Homework starts off with those. This is where logistic growth comes from. This is the rate of logistic growth. How do we solve this differential equation?
How do we solve it? We have to multiply the dt over. We have to
So let's do
divide.
this.
Ooh, no,
Okay.
it's gross.
So we have k, because he doesn't have a y. He's allowed to stay, but doesn't everybody else have a y?
Yeah. Oh, L's just a constant?
Yeah.
Okay, never mind.
Okay. Fine, I believe it.
That
And
makes sense.
integrate.
Like how does it look?
So it is separate. Oh, did not move what I meant to move. There we go. Uh-oh. The only way to solve logistic growth is partial fractions. And so we had to solve partial fractions first. KT plus C is easy though. Yay! Question, what's on top of y?
L? No.
Cover the y, plug in 0. 1 over L. Check it, right?
Yeah.
They're linear factors, so cover the y, plug in the 0, 1 over L minus 0 is 1 over L. Now, cover, plug in L, oh. Aren't they both 1 over L? Wonder who L is.
Is it the initial?
No? We could guess.
Wait a
So
minute,
limit.
is this one is this one a hard method? Oh, no, it's not.
And then,
No, we're doing partial fractions.
so then we get 1 over,
Our method's opposite. If there's one thing on the bottom and two on the top.
Well, wait. Oh, like it's a
Our
plus.
method is a common denominator, pulled apart.
Yeah.
We're splitting up the denominator of partial
Yeah.
fractions.
we
we
get
can
out
do-
of 1 over L.
Uh-huh. And it's going to be ln of y, right? Because
Yeah.
u is and then dy. So ln of y plus ln of,
There's a negative effect.
Ooh.
Oh, negative.
that'd be a u prime of negative 1. Don't we have to subtract?
Yeah.
Good, good catch. L minus 1. Okay. Now what?
Divide them.
And can I multiply L on the other side too?
Yeah, so
Okay.
LKT plus C.
And then L times c is just the other c, right? And we're going to have ln of y over L minus 1. Okay.
E it.
With e it.
Is that a better way of saying that?
Take E and raise it to the power of that number.
Do perform e to the power both sides? Yeah, it's not super snappy. We end up with y over L minus y. Y we're taking it to absolute values because this c can become a constant, right?
And then we can. No, we can't.
Okay, come on. You've done this before, but it always tricks you.
Are you gonna say?
How do we get this y one?
But then we have to get the Y back.
That's true. But at least we've gotten rid of the division.
How do we do that?
Oh, you should,
Oh,
Yeah.
God.
that's what I was gonna say.
Yes, above.
Sorry, Misty, I'm a little behind.
So LCE to LKT
Where's
minus
where's
that
that going?
divided by Y.
No, that was a question I knew the answer to for once.
And then plus.
Add it over.
And divide by. That's
And then
so
can't I just can't factor out the y as I add it over?
Yeah.
Okay. Nice.
When you literally are just using letters for all of them.
Right?
Oh, math has numbers.
This brings me back to ninth grade geometry when Mr. Shanks explained to us that like sometimes his notes would be like a full sentence in symbols. I don't know.
That's because you use,
No, it wasn't shorthand. It was like geometric symbols, like the sign for angle
I remember that.
and the sign for like or the sign for like theta and the sign for angle. So yeah, that's what he does. We teach you geometry now.
And
Now,
on-
here's the tricky thing. Don't you guys see how there's that CELKT in like the top and the bottom?
Well, we can't kill it. That's killing something.
We can or we can't. And I'm just trying to prepare you for the formula that we're going to memorize. You have to integrate this every time. You don't need to do this every
But it
time.
was one of
Kind of
our.
like exponential growth.
Isn't it on one of our servers?
Yeah, it's gonna be one of our endeavors. 1 over, I know. Just shh, just shh. Just shh. Okay, so
Hey.
Math is so weird.
that reduces, right? This needs to distribute, and you're like, this doesn't make
I see
anything
it.
easier.
Yes, it does. 1 over CE to the KT or LKT, and then you bring it up.
Wait a minute. No, that's the formula for, that's the thing for, logistic growth. It's CE to the negative LKT.
What did you what's the Miss T?
It's gonna be C plus CE to the negative LKT, because it's like, that's the formula for logistic growth. What's the word? Function.
Where did you get the C?
No, wouldn't the C go up with the E?
CE to the.
Wouldn't it go up to the E? With the
She has a CE, but she cancels the CE. The LKT. Don't you?
Oh, true.
Next page.
Should I want
What happened? Why do I have the, yeah, I shouldn't have the sticky link. Hold on.
Because it's y
You see what I'm
equals
saying?
L over 1 divided by CE to the LKT plus 1.
Yeah, so wouldn't it be 1 over CE to the LKT and then plus CE to the LKT over CE to the LKT, so they cancel, so you should have L over 1 over CE to the LKT, right?
Oh, plus 1. Okay, yeah. Sorry, give me a second to track that with you.
Sorry.
And then 1 over C can be a new C, yeah?
Oui.
Haha.
Not sure.
I got stuck with that first C. Actually, mostly there. Okay.
Bloody C.
Oh, it's in Revelation. Okay, so,
Is it Revelation or bloody C? Oh, I see what
this
you're saying.
is Egypt, it was.
Different types of C.
Okay.
I was like, no, there's
Woo!
no yes.
Where is he? Woo!
Ew.
Lice minus lift. Dun, 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 Right?
Because it looks like life.
minus lift.
I like the lady looking at boogers.
This works, it works. There you go.
Can you go back one?
If you try to-
So,
picture of me licking my nose.
wait, why?
Finish writing.
Okay, everybody else, 7.5B. Logistic growth. Aw,
finish?
come on. No, we're gonna have to finish tomorrow. That's okay though. But kiddos, hold on. Can I go back to the picture? Oop, this one.
Of course, this thing.
What's our endeavor gonna be?
Less more slick.
We're gonna have the amount equation, right? After t times the amount y. L is the limiting capacity, C is just a constant, K is whatever. We're gonna have a differential equation that we're gonna have to memorize. So you have to recognize this is logistic growth, recognize this is logistic growth, and recognize that it will be increasing most rapidly without taking the derivative and the derivative again and the maximum of the first derivative. First gonna memorize it's always at L over 2. It'll simplify all of the logistic growth problems that you might see.
Please tell me that's gonna be all, this whole page is gonna be an analysis.
If you want to memorize it, it'll count.
No, just the part where it says y equals L over 2.
No.
And the lice. Or the
Oh, too bad I can't draw. So I
This page.
Lice is
There you go.
multiple louses.
This page. Except, I don't like this variation, and I really don't think that I've seen it on any AP, so I'm just going to erase that variation and just give you it. There we go. Okay. Endeavor, number, I'll figure it out.
And number n. You call it number n.
True.
I get
N
it.
plus 1?
Oh, and
Integration by
infinity.
parts will make n. Then this will be n plus 1.
And no, and then a.
Are we not done yet? Oh, we have 25 seconds. Guys, I could have made you kept writing.
Coulda, shoulda, woulda.
Aww. Oh well. Let me get rid of this formula again, because once again, I've been looking at problems and I didn't see it. I've only seen this one, so let's not confuse ourselves, huh?
Oh,
And
yeah.
while we're finishing off, I'm going to go ahead and throw him in there. I'm going to zoom out over here. I'm going to put a nice little rounded rectangle that's yellow around this shabam, and then we'll figure it out tomorrow. Kiddos, if you did not do partial fractions last night or catch up on section 7 point, the one before this, please do so for tomorrow. Bye, guys.
Wait, so Misty, I don't think I put 1 and ever down yet.
Neither have
Do
I.
we have some?
We have at least one endeavor on the notes online.
Yeah, we do. We do.
Hey, Misty, can I come in during sunset?
Do you need to write your notes?
Yeah, I don't know.
Joyce, if you like this video, like, subscribe, leave a comment in the description below.
Or
Please
don't.
leave a comment. It'd be so fun.